Every time your phone finishes your sentence or your camera instantly recognizes a face in a photo, it feels a little like magic. But it's not magic. It's the result of an idea that for decades, almost everyone in computer science thought was a total dead end. The man behind it was told he was wasting his career. His own PhD advisor told him to give up. But he didn't, and his persistence unleashed a revolution. So why is this man, often called the godfather of deep learning, now so worried about his own creation? This is the story of the man who taught machines to learn and why he's afraid they're learning too fast. To understand this revolution, we have to go back to a time when artificial intelligence looked very different. Our story starts with Geoffrey Hinton, a researcher fascinated by the human brain. He wondered, could a machine learn like a child? Not by following a list of strict rules a human wrote, but just by looking, guessing, and learning from its mistakes. This led him to artificial neural networks, systems inspired by the web of neurons in our heads. Now, this idea wasn't brand new. The first simple neural network, the perceptron, was actually built way back in 1957. But by the 1970s and 80s, the whole field had gone cold. Mainstream AI was all about what's called symbolic AI, basically feeding a computer a giant logical rulebook for it to follow. Neural nets were seen as clunky, inefficient, a fringe idea. This period became known as the AI winter, a time when funding dried up and the biggest minds in the field basically said, "This will never work." Imagine being Hinton, a young researcher, convinced you're onto something huge, but the entire scientific community is telling you you're wrong. Grant proposals were rejected. His PhD advisor at the University of Edinburgh literally told him to drop it, seeing it as a career dead end. But Hinton had this unshakable belief. He saw that a web of simple digital neurons could, in theory, learn to see the world in a rich, layered way, kind of like our own brains do. He was so committed, in fact, that he left a research post in the United States for Canada, partly because he was uncomfortable taking funding from the US military. He landed at the University of Toronto, where he quietly gathered a small team, working in the background for years, laying the groundwork for a future almost no one else believed in. For a long time, neural nets had a huge problem. You could show one a picture of a cat, and it might guess dog. Okay, so it's wrong. But how do you teach it to be less wrong next time? How do you tweak the millions of connections inside the network so it gets closer to cat? The answer was a technique called backpropagation. Now, the core math for this was actually worked out by an engineer named Paul Werbos in his 1974 PhD thesis, but it was a seminal 1986 paper by Hinton and his colleagues that showed the world how powerful it could be. You can think of it like this. After the network makes a guess, the algorithm sends an error signal, the gap between dog and cat, backwards through the network. As the signal travels back, it nudges each connection a little, telling it how much it contributed to the mistake. Do this over and over, millions of times, and the network slowly, but surely, learns. It was brilliant, but there was a catch. For years, it was mostly just theory. Computers weren't fast enough, and they didn't have enough data to train on. The AI winter dragged on, but Hinton and his team kept pushing. Then, in the 2000s, two things changed. The internet exploded, giving researchers mountains of data to work with, and the development of powerful graphics cards, or GPUs, gave them the raw horsepower they desperately needed. The stage was set. That moment arrived on September 30th, 2012. It was the annual ImageNet competition, basically the Olympics of computer vision. That year, a model from Hinton's lab named AlexNet, created with his two students, Alex Krzyzewski and Ilya Sutskever, didn't just win, it crushed the competition. AlexNet achieved an error rate of 15.3%, more than 10 percentage points ahead of the runner-up. A leap that big was unheard of. It sent a shockwave through the entire field. Suddenly, everyone paid attention. The decades of skepticism just evaporated. The AI winter was definitively over, and the deep learning revolution had begun. Google acquired Hinton's startup for $44 million, and his fringe idea was now at the very center of the tech world. The world had finally caught up. The accolades poured in. In 2018, Hinton, along with his key collaborators Jan LeCun and Yoshua Bengio, received the Turing Award, which is often called the Nobel Prize of Computing. After a lifetime of working in the shadows, he was vindicated. If you think this story of persistence is as incredible as I do, maybe take a second to subscribe.